In this example, we're going to solve a three-dimensional trigonometric problem. Before I introduce the question, I'd like to show you this little model that I've created to introduce a very important concept, that Pythagoras' theorem works in 3 dimensions as well as in 2 dimensions. So in the diagram here, I'm showing a diagonal going from point P to Q inside a cuboid. And it turns out that the square on this diagonal, a squared, is equal to b squared plus c squared plus d squared, which happens to be a right angular pathway to get from P to Q. And it turns out that any right angular pathway that you can take to get from P to Q, if you square each of the sides and sum these squares, it will be equal to the square of this diagonal. This is also a very useful concept when we're being asked to solve problems dealing with pyramids. The slant height A here will be equal to b squared plus c squared plus d squared, a right angular pathway to get from one corner of the pyramid to the apex of the pyramid. So we'll see this applied in the question we're about to do now. Here we have a problem that's using 3-dimensional trigonometry. We're going to learn that Pythagoras' theorem actually works in 3 dimensions. So we have a pyramid, and we've been asked to find the slant height, AV, of this pyramid, colored in orange here. If you can find a right-angled pathway to get from A to V, well then Pythagoras can be used to work out this slant height. So we see if we go halfway across between A and D, that would be a distance 2, and then into the point O, that's a distance 2, and from O to V, well, the pyramid height is a height of 3. Here we're making this journey in green by turning right angles. Therefore, the slant height, x squared, would be equal to 3 squared plus 2 squared plus 2 squared. It's a version of Pythagoras' theorem. So if we square root both sides here, we can see that x would be, I'm going to use the calculator, is the square root of 3 squared plus 2 squared plus 2 squared, which is 9 and 4 and 4, which is the square root of 17. We're now also being asked to find correct the nearest whole number, the total area of the 4 triangular faces. I'll draw one of them here. It's isosceles. We know its slant height is root 17 on both sides. It has a base of 4. If I break it in half, I could turn it into this right-angled triangle with a side of 2 and root 17. Using Pythagoras' theorem on this, we can see that the other side is the square root of 17 take away 4, which is root 13. So now I could use the half base by perpendicular height formula to get out the area of each of these triangles, because I know its base is 4 and its height is root 13. I'll just draw it out again. So we have 4 of these triangles. So the area of one of them is its base, 4 times root 13 divided by 2. So 4 of these, giving the total area, is 4 2's, which is 8 times root 13. It's most accurate to leave the answer in this third form. However, if you want to correct it to the nearest whole number, it will be 29 meters squared. And the units are important in the answer as well.